Welcome back. Hope yesterday went well. There are solutions posted to yesterday's work, so make sure you checked and really look at things that don't really match up and make sure you understand what you did, why you did. If it's finished and ready to turn in, go ahead and you can stick it in the bin or have my paper person for your bell pick them all up and stick them in the bin so not everybody has to get up. Today we're going to work on more rational equations rather than graphs. So on the test, you did all kinds of things about solving rational equations. Remember, we found out what we thought the common denominator would be. We didn't actually find common denominators, but we multiplied both sides by what the common denominator would be to kind of get rid of all your denominators of your fractions so you had a nice, easy equation to solve. Today, we're really going to focus on how do you write those equations for a certain situation. You do still have to solve them and come up to an answer, but that's the part you already know how to do. So really what I'm going to talk about is the focus of how to write those equations. So there is a worksheet, and you'll notice that there are, at the very end of it, there are all kinds of hints for the problem. So make sure you try them first before you start looking at the hints, because you're going to want to be able to really try to think about what you're doing, because again, this will be on your next test. A couple hints as far as general things I wanted to talk about to kind of help you along since I'm not there. The first one is there's a lot of distance, rate, and time type problems. Maybe not a lot, a few distance, rate, and time. So you know that distance equals rate times time. So if I'm going 60 miles an hour and I drive for 2 hours, I'm going to end up with 120 miles. So as you look at these distance, rate, and times, you have to figure out what you know, or what kind of information is given. If you know that two people go at the same speed or the same rate, you can write an equation. I don't know why this always works before, but it doesn't write very well. There we go. D1 over T1 equals D2, this is getting worse, over T2. There we go, kind of. D1 over T1 equals D2 over T2. Not that you can read that. If you know that the time for two different people is the same, but maybe they're going different speeds, or maybe they have different distances, if you know the time is the same, you can go D1 over R1 equals D2 over R2, and then solve that equation. If you know that the times add up to something, maybe you know the total time is 4 hours and you don't necessarily know how much is one direction or how much is the other, you would have some kind of equation that is like D1 over R1 plus D2 over R2 equals whatever that total time is, if you're given that. So you have to kind of look at what you're given and what you want to know, and then you can solve that equation. If you know that one rate is faster than the other or one rate is slower than the other, you can always make R one of the rates and the other rate R plus 1, or the other rate R minus 1. So think about doing those kinds of things on those problems. The other big kind of problem that is on there are mixture problems. Mixture problems are really when you're combining, that's why it's a mixture, you're combining like different people's work together, whether it be how fast copiers make copies or how fast people paint walls. And there's kind of a generalized formula, which you see on your screen. Time together divided by time alone, and the plus ... plus means you can have as many different people as you want. So if we were doing this with 5 different people, if we said we have 5 different people in the class are going to come in over the summer and repaint my room. So if we all work together, I want to know how long it's going to take if we all work together. So that might be, if I want to know how much time it'll take for everybody to work together, I've got time together over time alone. So maybe it'll take the first person 6 hours. Maybe it would take the second person 8 hours. Maybe it would take the third person 5 hours. Maybe it would take the fourth person 10 hours. And the last person 7 hours. then you just need to solve that equation. So you have a fraction for every piece, everything that's working together. So if there's 3 things that are working at the same time, then you have 3 pieces to it. Now, each one of those fractions is less than 1, because the time it would take you to do paint the whole thing together is going to be less than it takes any one person to do it, right? You're kind of like you're sharing the work. So each one of those pieces is kind of in some ways, the percentage of what part each person does. And then if you add up all those percentages, it equals 1, because there's one job that needs to be created, one job that needs to be completed. If I had already started painting the room and I'd already had half of it done before anybody got there, so the five of you who are going to help me finish this, you then only have to complete half the room. So then it would be equal a half, because you're only doing half the room. If you're only doing 2/3 of the room, you'd only complete 2/3 of the room. So if you really think about kind of how that works, that'll kind of help you set up the equations for those. But the key is that each one of these fractions is less than 1. And they can be negative if they're working against you. So like if somebody came back and put graffiti on a wall, did something to make it take longer, then that would be a subtraction kind of thing. And all of those fractions add up to the total amount of work that has to be done. So a lot of times that's 1 if it's a whole room or a whole whatever. It can be less than that if part of the job is already done. So make sure you really think about the equations, try to figure it out before you look at all the hints. And then you certainly can work together, talk together, really work on trying to understand how you write the equation and why it is the way it is. Hope you have a great day. Talk to you soon.